or to the people who will see it later, we are Python Milano, organizer of 2 monthly meetups, or we try to organize 2 monthly meetups. One is called Python Milano, is the original one for everything Python related, and we started also 2 years ago, PyData Milan. We try to have them one the first Wednesday of the month, and the other one the third Wednesday of the month as a default value, but this default value is frequently overridden. Other things we organize are the Intervista Pythonista. The hosts are Cesare and Marco. Who knows who might be one of the next person here. I'm looking in one direction. We organize sometimes not only talks, but peers or wherever. And we organized already a couple of times a Python conference in Pavia, Py4AI. This is the most important thing that you have to remember. It's pretty simple, milano.python.it, and you find all the links to the meetups, to the channels, Slack channel, Telegram channel. We have too many channels. I will try to monitor the Slack and Telegram channel later for the AMA. Ask me anything. Another quick announcement, we have a community discount for a Eurorust workshop by Luca Palmieri, 8th October in Paris, 20%. Code is PyMilano. You find it also on our channels, Slack and Telegram. We thank our partners, the Python Software Foundation, who supports us, Division Lab and Alessandro Re, who is responsible for a lot of the video setup that allows us to stream and record, and Python Italia for also sponsoring some of the recording equipment for Intervista Pythonista. And you have the YouTube page with the link of the stream of today. We have to thank our hosts, which are many. Today we're Antiv Systems. This is the new slide. Sorry, I updated it. So we have already had a number of hosts, different hosts in 2025 and in 2024. They seem to like us because they ask us to come more than once. So we are probably not too bad. Just a quick announcement. If you haven't heard about it, Python documentary, it was out 1 week, 2 weeks ago. Is great. Just watch it. This meetup is co-organized also with AgileLab, of which I am also an employee, also as part from Python Milano, who provided the original link with Jacopo. And I will not say much. I think the most interesting thing I can say about the company is that we have a public handbook in which you can find information about how we run the company. We also have a careers page, of course. And this was the presentation by Mark of Team Systems. So we double up. And the last announcement that also Luca made after the meetup. So after we go out by 9 o'clock. So we have to get out or be already out at 9 o'clock. So start. And for this time, we don't have even to reserve a place. No. Okay, let's not talk about sponsoring, buffet or other things. Let's forget about it. You haven't heard anything about that. Okay, so it's really a great honor to announce the speaker for tonight, who is Jacopo Tagliabue from Bauplan. Maybe one of the most famous Pythonista from Milan. Who knows? Who will start with a technical talk about speedrunning the Lakehouse. Welcome, Jacopo.
Thank you. Can you hear me fine with the mic? I think it's okay. Can you hear me fine? Okay. Can you guys hear me fine? I'm gonna shut. Yeah, awesome. So thanks so much everybody for coming. I know everybody's very tired, so I will try to make this technical talk as short as possible, and then we can dive deeper to some questions. I'm apparently the most famous Python person from Milan in a ranking of like 4 people probably. But for those of you, if you're here, you probably know me or know of me. But just in case you've been under a rock in the last 10 years, or you have much better things to do in your life than doing Python, I'm the co-founder and CTO of Bauplan. Bauplan is a startup backed by top Silicon Valley investors and a bunch of people that you probably owe a great deal to. If you ever write one line of pandas, poor you, but the person who invented Panda is called Wes, which is one of our friends and investors. If you ever use Arrow, this also goes back to Wes. Spencer Kimball, which is the founder of CockroachDB, like a few billion-dollar company. Chris Ray, MacArthur Fellow, and one of the most important person in AI today. If you ever use a transformer in your life, use something called flash attention. That's the guy that invented it, across a million of other stuff. This is my second company. My first company was called Suzo, and it was doing NLP, natural language processing, but that was still hard to do. There was no API, there was no import tag in face. It was just like you actually had to know what you were doing, which is not, sadly, the world we live in anymore. And I spent the last 10 years up and down the stack in what I call friends-driven development, which basically means that I have a very smart friend, much smarter than I am, and so I tag along with their adventures, and we do a lot of cool stuff together. So at the intersection of these acronyms, I'm probably the only person at the intersection of these acronyms. You're gonna find most of my research across almost all parts of computer science. And if you have ever bought something on Zalando recently or visited Vogue, you probably have interacted indirectly with some of the models that I open source in my previous life. So this is the talk that I gave last week at VLDB, which is the most important conference on databases, where I had a keynote. This is a short version of it. And so for those of you who remember that from the 90s, this is a short version of the talk to accommodate the constraints that we have. So of course, I'm the only person here today, and but I'm not the only person at Bauplan. So whatever credit, whatever value my idea has, the credit should go to also like a few other people, like they're in the slide. Some people are not in the slide because they don't have achievement, they will ruin the slide. But the general idea is that, of course, you don't build a company by yourself, you build a company with your team. If there's any remaining mistakes in this presentation, it's entirely their fault. So what is Bauplan? We're going to talk about being about there, but it's a lake house, and I don't know how many people are familiar with the term, but we're going to go into that. And the idea is that for the philosophical idea is that for the last 15, 20 years, we have been treated data as kind of like everybody ate a data organization. Data organization never produced any real measurable value. They're always stuck in backlog. And up until a few years ago, when the revolution was not run by data people, but was run by OpenAI and all those people, data was perceived in many, many occasions as a center of cost, not as a center of value. And that's a sadly state of the field, where many data leaders have to justify the ROI of their work constantly. And one of the reasons why we believe is that the case is that because people have treated this thing as its own special little thing, instead of treating like something that we know very well how to run, which is software organization. And so Bauplan, at the end of the day, is the idea that data is much, much more similar to software than we were led to believe, and that the more we make it closer to software, the better it will be for us, data people, and for humanity. So this talk is called Speedrunning the Lakehouse. I don't know how many people know what speedrunning means. If you know what speedrunning means, you're an awesome person. It doesn't matter what people in high school used to say about you. But if you don't, speedrunning is the challenge of completing a video game as fast as possible. So I don't know if you're old enough to remember Mario 8-bit from the NES. So the world record is 4 minutes and 54 seconds. If you've never seen a speed run, I would suggest you to go on YouTube and check out one. Is much better than this talk, and it's really fantastic. But what is the crucial intuition about speed running? Like, you're not gonna beat Mario by pressing like furiously on the fucking thing. Like the people that complete Mario in 4 minutes, they're not very fast thumbs, right? It's obviously stupid, right? You're gonna shave 20 seconds out of 20 minutes if you press faster, but you're not gonna go to 4 minutes. The way we choose speedrun things is because you find a trajectory in the state space that nobody else had thought of. You find a way to jump entire screens, entire levels, because you figure out something that other people don't. And that's kind of like what we did at Bauplan, right? How do you speed run something? You try and do something that nobody else is doing. You're not just trying to do something that everybody else is doing, but just a tiny better. I'm not going to name names, but I mean Microsoft. So if you go online and you can say, "Oh, speedrunning a Lakehouse, are you fucking crazy?" Like you can go online and just Google, and you can find out other people doing a Lakehouse, right? And so you can find like a small player like Dremio, which is approximately valued to $2 billion. You can find Snowflake, which is now around 60 because they said AI many times in the last earnings calls. Databricks recently valued $100 billion if you believe private VC evaluations, and fairy tales. And then finally Fabric, which is the unknown value, okay? And so this is not a scale because I'm terrible at math, but it's just to kind of give you the feeling of this. Like, of all the things you speedrun, how can you fucking speedrun a lake house? Like, are you crazy? How can 5 Japanese characters build something that literally thousands of people at Microsoft cannot do properly? And so the answer to this is basically 2 things. And one is simplicity. And it's like, again, people led you to believe that there's a lot of clicking around and a lot of, bullshit, bloated software that you need to get data in production, and that's false. It's just been sold complexity by merchant of complexity. Okay, so if you can design a system that is much, much simpler, we'll do basically everything else that the other system does, but much simpler. And the second is composability. Composability is the theory in data system, is a philosophy. There's a composable data system manifesto by Wes McKinney and other fine folks that basically says that data in the infrastructure, so not maybe as a user, but as software, the problem of closed source and vertical integration, right? Think about your typical application layer stuff, right? The first thing you do when you open a Python program is importing something that somebody else wrote. Almost nobody here ever wrote a single script without importing something that somebody else wrote, okay? That's false when you build data system. Most data system they use today has been basically vertically integrated and built by people without any sharing of absolutely anything. If you use Postgres, Postgres has its own query optimizer, query parser, physical layout, storage engine, and all of that. If you know how a database works, it doesn't really matter. If you go to Snowflake, which is technically a database, they have their own query parser, their own query optimizer, their own query logical planner, their own storage, and all of that, okay? And so some people 5 years ago said, well, this is stupid. Like, we're keeping on reinventing the wheels, which means that building a data system costs hundreds of millions or billions of dollars because everybody needs to build everything from scratch, which is the opposite of what everybody's doing in any community, including the Python community, right? We build on each other's work. And so there's this idea that you can kind of take apart a database. You can open a database and you can kind of identify different layers, and this layer can be shared across different systems so you can build one effectively, okay? And so the combination of these 2 ideas is how you speedrun a lakehouse. Lakehouses are great for many reasons. Contemporary lakehouses are great for many reasons. But one thing they're really not good at is being simple. You can search on the web. This is not generated. This is literally plain old YouTube. You can go online and say lakehouse tutorial, and you find this kind of thing of like, sure, you want to learn a lakehouse? Sure. Do you have 4 hours and 17 minutes to give me for that tutorial? Of course we can learn in 4 hours. But even worse than that, at minutes 19, so 20 minutes in, we're still describing this bullshit thing of how this works. So 20 minutes into the job, we haven't written a single line of code, we have no idea what's going on, and we still have 3 hours and 40 minutes to go to actually run something. So this is the state of, of the data system today. And the reason why that's the case, among many, is because lakehouses evolve to serve different purposes for different people. So you start by querying something, and then you need to build a pipeline. Then you need to schedule something at night. And the easy way to solve this heterogeneous set of business cases is to just add complexity. Do you want a query? Let's add a warehouse. Do you want a pipeline? Let's add an orchestrator. Do you want to develop something? Let's do a local development, then push something, build Docker, send it to ECR and something like that, right? And so, in fact, the life of somebody in a modern lakehouse, even a modern one, even a good one, not Microsoft, like even a good one, is going around and clicking for their entire life or learning completely different abstraction in the entire data lifecycle, right? Such that, even very, very big and traditional company in the lakehouse space have 1/3 of their employee as solution architect. So imagine having a company where 1/3 of your workforce is devoted to explain how that works to the outside world, right? Is there a different word? And we believe it is. And this is the equivalent of how you actually run things in Bauplan. You open your terminal, you do pip install Bauplan. You check out a branch, which is just a branch like the one in your code, but this is a branch of your entire data states, and then you run something. Since Bauplan is available as a sandbox online, you can go on Bauplan Labs today and try it out, so you don't have to trust me on this. The only thing I want to say, because it's going to be useful for what follows, is I want to give you just a tiny feeling of how different it is from anything else you ever seen in your life. Again, you can try it yourself. So I don't know how much you see, but Bauplans are pipelines are just function. There's a parent function, a child function. The child function replace the results as a table. The parent function read the taxi dataset and the taxons on dataset. And here we are creating a branch. It's called Jacopo VLDB. And now we switch our entire data lake to this branch. So we're basically sandbox our entire stuff. Do you want to explore the data? It looks like, pip. It looks like Docker, sorry. Do you want to run it? You just do Bauplan run. When you do Bauplan run, your entire code gets sent to the cloud. None of these run locally. All of these run remotely. It builds 2 containers, read the data from your object storage, pass the data around, print the statements as you see them in the code in real time, and then write back. So 5 million rows in 10 seconds. You want to see the table, they would just materialize. You know the syntax, just table get, and you do it. You want to change. You say, oh no, I want Python 3.11 here, and I want to change polars here. How do we do it? Oh, I also want to run more rows now. Instead of running, a month, I don't know, I run something more. You change it, you just do Bauplan run again. Let's see how it takes to rebuild the functions. 100 milliseconds later, you have a new function with new dependency and all of that. And now you run, do I remember? Maybe 20 million rows? Yes, 20 million rows is going to run again, end-to-end reading and writing to object storage in 20 seconds. If you've never seen this before, you already know half the platform. There's literally nothing else you need to do. And it didn't take 4 hours and 70 minutes. It didn't even take 5 minutes to go from, hey, I have some code I want to run on the cloud at scale. Again, you can try it yourself on the sandbox. So first principle, how do you go from all this bloated 4 hours of clicking around software to 10 minutes onboarding for everybody? And the first thing is like simplicity. We're gonna analyze this sample pipeline as a sample example for the rest of the day. It doesn't really matter what it does, but imagine a typical situation. We have some transaction going on here in a source table. I see people from the credit card world here. There's like some transformation. You just do select, for example, which country are in the euros, and then you're gonna aggregate them by country. Right? Doesn't really matter what the code does. This is a typical DAG in the sense that you go from a very generic tables and you go to the end of the table by basically adding function one to each other. Okay. And so when you do Bauplan run, which is what we did in the video, what happens is a typical, data system. I'm sure, people here will see many of them. You send something to the cloud parses out the code. Remember that you see the code and then the small diagram. So you understand which function is the parent, which function is the kid, makes and check the data catalog, and then it sends it to your workers in your AWS. These are standard, very, very vanilla control plane, data plane distinction. It doesn't really distinguish Bauplan from anything else. What's weird, so what makes Bauplan different, is that what happens when things actually run. So when things actually run and process data and start sending you events to your laptop. The first thing is that pipelines, like the one that we saw in the video and the one we're doing, are basically just chaining function together. Like as an abstraction, is a very easy thing to understand. Do you want to read a function? You read a function from, this is some iceberg, some table in object storage. You're going to output a table. This table is going to be sent as an input to the other function, and you go around and around. If you stack enough pipeline to give enough function together, you're going to get a bigger pipeline. Okay, you can do Python, you can do SQL, it doesn't really matter. The idea is that you read from some functions or some table, and then you output a table. If you're familiar with something like DBT in the SQL world, that's kind of the same syntax, just a bit more polished. Okay, and that's obvious. That's kind of like relatively obvious. What is really weird is that Bauplan treats also queries like function. So when you run a query in Bauplan, which I didn't show, but you can totally do. You can say Bauplan query, and then you launch a SQL query. What happens is that the system actually runs that as a pipeline as well. Okay, it's a weird pipeline. It's a pipeline that have a function that you don't see, which is the pipeline that reads from object storage, whatever tables you want to read. It injects that into an ephemeral function running a fork of DuckDB. In this case, is going to be soon Data Fusion, and then it sends this over to a server that starts streaming data in real time to your laptop. Even the server itself is a function, is an ephemeral function that gets spun up, which means that even query, which is something that you perceive as a user as a monolith, as one thing that you send and you get back, are actually a pipeline. Okay, and a pipeline is a series of functions. Why does it matter? This matters because it means that we can run everything using the function as a service model, or as I call it, the only FaaS. Okay, so everything is actually a function. Okay, what is good about function? There are a few things good about function. From the point of view of the user, is that every user knows what a function is. We have people learning Bauplan, like intern at our customers, learning Bauplan in the first day of work without any absolute knowledge of like how the cloud works, how container works, how data works. They know a bit of Python, they know what a function is, that's enough for you to get started. For me, as a person building the system, it provides a unified compute model, which means that the only problem that now I have is that I need to schedule functions, which we're gonna see is a kind of a tricky problem, but this is one problem, okay? And that makes it very, very different than what everybody else is doing. Remember, we're speedrunning. We're not pressing the button slightly faster than anybody else. We're doing something completely different, okay? And the thing we're doing completely different is that we don't do any of this bullshit, okay? What we do is that we basically run functions, okay? And so we take all these use cases and all this complexity that people have introduced in the Lakehouse world in the last 10 years, and you squeeze them to one single axiom, one single concept. Everything is a function, okay? So can we reuse existing function as a service? Because I don't want to build one if I'm not forced to. And the answer, unfortunately, is not. If you are familiar with typical FaaS system like AWS Lambda or OpenWhisk or OpenFaaS, they're built for a world in which functions are run as endpoints. They're short-lived, they're completely independent, and they mostly do trivial stuff. Okay, which is the opposite of what data is. Data is kind of like low concurrent, vertically very big, and it may take an hour to run a function. So nothing you can actually reuse from the open source, so we actually have to build it. I'm gonna skip this. So an important part of how this is built is, okay, we need a new way to express our thoughts, and we're gonna divide the labor between us and the users in a very clear way. So these are Bauplan functions, the same that we've seen before. Like, again, even if you've never seen it, it should kind of be sort of trivial for you to figure out what's going on there. Users write the code here. So the body of the function is your job because it's your data, it's your business, it's your pipeline. We have no idea what's going on there. You can pick whatever package you want. You can pick SQL, Python, whatever you want, okay? The only thing you need to abide is the signature. So you need to receive tables, and then you need to return tables. That's the only thing you need to abide. Everything else in between is yours, but you need to receive tables. They can even be tables in the same DAG or tables in the lake, and then you need to output tables. And then you specify your infrastructure here, completely declarative in code. No Terraform, no DSL, no YAML, no nothing, no Docker file. You just specify here. And then, again, we chain IO, right? So we understand that this function here is the parent of this function here, so we know which one we need to run first and we need to run later, okay? So the user runs the code, we do everything else, okay? So we make sure that when you run the code, the container that runs the code has exactly what you say it has, and the data that you want to be there is actually the data that is there. And so we need to build this or runtime from scratch. And so, it's an enormous amount of work, and it's actually very hard. My previous company was in application layer, was doing machine learning, and then we built this company in the infrastructure layer, so the layer below. And you know what they say, we didn't do this because it was easy. We did this because we thought it was easy, but it's actually really not. So infrastructure is really, really hard. And so a huge amount of our time, even as a short company, is to build this complete new runtime that gives you the feeling that you see before. Like immediate instant execution in the cloud with 100 millisecond Docker container startup and everything else taken care for you. This doesn't exist as out of Bauplan, and we build it from scratch. So when you do a Bauplan run, there are three things that happens. We're gonna kind of go fast through this because I think it's relatively interesting, and you can find it online in many, many papers we published. So what is our challenge? So, okay, I gave you a new way to express your thoughts, okay? But now this way is too high level for a computer to run. So they need to map whatever you want to do here with something that actually I can build, and whatever data you need here to something that I can actually fetch. Okay, so how do I do that thing? And so we do this with a sequence of operation that really resemble like a database work. I don't know how much you know about databases, but like there's a sort of a logical layer here, which is just representing what the user express. There's a physical layer which attached to each of these nodes, physical operation that needs to happen for you to actually run. And then finally, there's a privileged view of the worker that received this and is able to optimize a bunch of stuff. For example, is able to transparently cache stuff to reuse packages and so on, which is the reason why this system is so fast. The second time you run it, the system is smart enough to know, for example, a taxi zone didn't change, and so it's going to reuse that instead of fetching from S3, which again gives you the type of performance that you saw. So how do we build containers so fast? I'm just going to do this for the nerds in the room. If you don't care about how containers are built and you want to wait 10 minutes of your life every time you do Docker build, you're happy to do so. But the way in which we do it is by basically taking apart your request, which is polars, and we don't do pip install. We don't do requirements. We don't do UV or any of that. What we do, we actually take it apart and build the transitive dependency graph of polars, right? So you have a top-level package, and then you have a bunch of packages that builds up of these packages. Again, you're familiar with Python, so you know what I'm talking about. Then we send it to the worker as an instruction of things to build. And the cool thing is that since we send all the packages completely separate, the worker can pick and choose the one which need to be installed and the one to be installed previously. What does it mean? It means that when you change a version of polars, which is what I did in the demo before, a huge part of packages that composes Polar are actually going to be already present in the cache because base level packages change not so much between versions. So the system is able to automatically basically diff your entire package and reuse the package that you have and just install the one that you don't, plus the fact that everything is cloud, you're not bottlenecked by bandwidth because you're going to install from AWS directly, okay? And then when you build a container, you don't build the container, you assemble the container. So you start a container with mount as read-only the Python folders in the cache, and then the container starts up, okay? This is how we can build a container. Like you can do the full container loop like approximately 15 times faster than the same things will take you to build with AWS Lambda, and still 7 times faster than Snowpark. If you don't know what Snowpark is, no worries, nobody does. There's a few cool things that you get out of this, not just performance. We don't have to manage states. All our function dies immediately, and they're spun up automatically. Nothing ever persists more than one time. Why? Because it's so fast to build a new container that there's no reason to keep containers around. So the system is very, very easy to reason about. Again, remember, simplicity is one of the reasons you can build so much with so little is because of like this obsession with simplicity at every level. Simplicity for my user, but simplicity also in how we design a system that is actually very robust and scalable. Second thing that is important to know, data movement. So we're very fast because every time you specify something, it actually gets fed to the function as arrow. Arrow is a very fast in-memory and over-the-wire format. It's been built by originally Wes McKinney and Jacques Nadeau, plus a lot of other people. Is the de facto standards in data movement as of today. All big players now are converging to Arrow, including Spark 4.0, Snowflake, and all of that. What is cool about Arrow? So Arrow is marketed as a zero-copy format, okay? And when I first encountered this term, I was assuming that zero copy meant that there was no copy, because zero in my dictionary means zero. It turns out that zero copy is the most bullshit marketing term in the system community. And when people say zero copy, they actually mean 1, sometimes 3, but sometimes 2. It's very clear. Unclear if you can do 0. But Arrow at least allows you to avoid this situation A, which is, let's say you build data pipelines with, I don't know, Airflow and Pandas, right? It's a very common situation, right? You shouldn't do it, but also there's a lot of things you shouldn't do. You shouldn't smoke, but people smoke. So you have Pandas. Pandas will serialize this to a over-the-wire format, let's say Arrow. Then you send the over-the-wire, and then you do the opposite on the other side, right? Okay, so this is the, A is like, naive, stupid way of doing stuff, okay? Arrow allows you to do this one, which is we cut one of the copy because there's no serialization and deserialization. And if you are in the same host, you can actually do zero copy by sharing memory. Again, it doesn't matter. This is a very system level thinking, but it doesn't matter. But the point is like you can count. So 1, 2, 3, 4, 5, 3, 2. So we're getting down, so better. And then the real question, of course, is like, can you do that? This is zero copy. Can you do this? Can you do this? I don't know. We're going to answer later. Why Arrow is cool? Because Arrow is actually very, very fast. So this is a typical academic table. For those of you who are not familiar, there's the last row. The bold one is we are very smart, and everybody else is an idiot on top of us. The only thing you need to take home is that reading a Parquet file from disk is actually the same amount of time than moving the same amount of data between two EC2s in the cloud, right? contrary to the history of computing where we're usually bandwidth constrained. Now we're not bandwidth constrained anymore. If you do everything in the cloud, first, the moment you open something is the problem. Like you're not bandwidth constrained anymore. And if you don't pay serialization price, you can actually shove a lot of data between instances very, very fast. Yeah, so if you're curious to know how you can actually do T, one of our papers is called Zero, which is this, zero arrow, okay? And it's called True Zero Copy Arrow Pipelines in collaboration with University of Madison, Wisconsin. Is open. Is under review. So this is the preprint, but the preprint is available if you're curious of how you actually can hack the Linux kernel to achieve that result. I'm gonna skip this. The second great theme that I want to talk about is the composability of data system. Again, data is kind of the special thing where data companies have historically cost billions of dollars to build, and they're all vertically integrated, right? If you go work in Oracle and you open Oracle, like you open the system, first you're gonna find 10 lawyers inside the system, yeah. But if you move away the lawyers, you're gonna find a bunch of technical depth and decisions that are completely tied to the Oracle system. Oracle has its own parser, its own representation, is all of that. Right, again, and I can stress this enough. This is very different than if you go to any of your friend company and open their, machine learning serving stack, okay? They're gonna have fast API. All of them are gonna have fast API, and they're gonna have PyTorch, right? And they're all the same. Like, there are certain level they're all the same. Databases are all different, okay? And which is why they cost so much. There are so very few people on the planet that can build one, okay? And so some people start to say, well, this is bullshit. We should have composability in the data stack as well. We should be able to build a great query planner, and I give it to you, and you can use it in your system even if the rest of your system is completely different. And so Bauplan is, I don't know if there's a ranking, but Bauplan may be the most composable system in production in the world. So when you do a Bauplan run, you saw the tiny thing you did before that looks like this kind of nice integrated experience. That thing, if you open the backend, is hundreds of traces. Like the amount of shit that goes on in Bauplan to give you that experience is actually mind-blowing, okay? So in one Bauplan run that you see happening in front of your eyes, there's like dozens and dozens of services that contribute to this final result that is kind of neatly packaged for you as a user. Some of these services are hyperscaler stuff, so S3, it doesn't go down. Or if that goes down, Bauplan is the least of our problem. To very obscure open source library that you have ever heard, to our own software. So all of this is chained together in hundreds of traces in a few milliseconds each to give you the experience that you have there. It would be impossible for a company of 5 Japanese cartoon characters, and a few others, to build a lakehouse and bring into production in a year without reusing what the community has been doing, right? This was our VLD paper in 2023 when we started the company. So this was kind of like a white paper, vision paper, and it's called Building a Lakehouse from Spare Parts. We decided to build the fast runtime and the abstractions for the reason that I explained. Nothing was good enough for us. Nothing was giving people that experience. So we built that. And then we reuse almost everything else. Our query engine is a fork of DuckDB. So when you run a query, that's what you get. Again, that's temporary. You're going to get data fusion soon. Our catalog is a fork of Nessie. Our Duck plugin is being of Kuzu, which is an ephemeral graph representation. And our Iceberg client is a fork of PyIceberg. So when you run Bauplan, you also run each one of these things at least once, okay? Which means that we need to become expert in managing and running, all of these things in production scale. We learned from the people that run Nessie that we are the largest Nessie platform on the planet with millions of branches, of data branches under management. In fact, we run so much on Nessie that we can't use Nessie anymore, and we need to rewrite entire functionalities to make it compliant with our use cases. In fact, our own Nessie is now 25 times faster than the actual Nessie. Of course, we give back as much as we can. For the size of our company, our contribution, I'm very proud to say that our contribution both to the open source and academic community is completely outsized. We publish, a couple of papers a year in top conferences, and we contributed to all the projects that actually make up for our stack. And that's a culture that we have as a company. We're sort of the only company that I know at our scale and size, even in Silicon Valley, that does this. And I'm happy to talk about that later. But it's kind of like part of our DNA, and we're very happy that we try to be good citizens of the community. Finally, and then we're gonna go to the conclusion because I guess everybody's tired. I'm tired. there's an interesting, so one of the most beloved features about Bauplan is what you saw in the beginning me doing. Like you can check out a branch of your entire data lake like it's Git, right? So people get into this idea that no mistake they ever do on their data is final. So everything you do with Bauplan is immutable, as in everything you do is recorded forever, you know, like a commit, like a ledger, but nothing is fatal. You can always go back to a previous state like in Git. And that's very powerful because it unlocks people that work with data this new thing, which is working like software people do, which is kind of like a more, you know, tried and tested way of actually bringing stuff to production. And there are two big questions that you start, you know, asking yourself when you go down that route. One is, how much Git is in Git for data? Like, how much of the beloved commands you have in Git or the, you know, demented command that we have in Git can be ported to a system that is analogically similar, but is not exactly the same? Like, what is a rebase for a table, for example? Like, there's a bunch of things you need to clear out. And so we have this series of blog posts if you're interested in formal methods. So we're interested in blog posts in which there's mathematical definitions of all the important concepts and a bunch of theorems they prove to describe how the system is built. The second question, this is again for the database nerds, but this is one of the most interesting things we've been doing this summer from a technological standpoint, is that if you squint, if you really squint, really squint, you can imagine that data branches are a way to manage concurrency, okay? And the reason why database exists, the reason why Postgres exists, right? Postgres exists because it manages for you this incredible thing that when two people try to update the things at the same time, Postgres will make sure that you don't ever read either half of the result of the other, you eat the entire transaction or you don't. That's the entire reason a database exists, right? It's called MVCC, okay, multi-version concurrency control, okay? And so when you look from afar, Postgres is kind of like this neat thing, all vertically integrated, is all custom built, like there's no composability in Postgres, right? And it's kind of like this thing that you have on your laptop with your desk. It's kind of like Switzerland, like it's so clean and orderly, right? Mm-hmm. And then there's your lake house, right? And your lake house is kind of like Bangkok, right? There's like, you know, a million fucking processes going around. One is Python 3.10, one 3.11, one is SQL, one takes a minute to run, one takes an hour. These two things could not be more different, okay? The surprise of it all is that you can actually prove that these things, you know, are similar to a level that is like, you know, they're almost the same thing. And by prove, I mean you can mathematically prove that. And again, we have a new paper coming out. I have a fantastic proof of this, but this slide is too small to contain it. But if you care about this, you know, look out for a new blog and a new open source code. This was our work with our fantastic intern from Carnegie Mellon, Columbia University in Madison, Wisconsin this summer on proving the equivalence between Switzerland and Bangkok into a certain level. So things that are composable or programmable, we're going to go very quickly through this. Again, you can go online and try it yourself. This is how you run a pipeline, but how you parameterize a pipeline to run? Just Python. You never seen this before in your life? You can just see how it does. You can just run a for loop. You can create a branch. You can run a pipeline. You can merge a branch. This is not pseudocode. This is the real Bauplan code. There's no manual. There's nothing you have to learn. This is literally what it looks like. You can go in your IDE, press a dot, and it's gonna auto-complete it for you. Like this is the entire thing. There's no TSL, no Terraform, nothing to run. If you want to run 7 versions of that pipeline on 7 branches, a for loop that you know that a first-year university student can understand. Who cares? So yeah, so we're really proud of our APIs. I don't know if you know the API ladder. API ladder is a fantastic concept of like how you should build good APIs. So there are 3 steps for good APIs. So in order to get started, this API needs to be convenient. Like, you know, again, it needs to be so easy to start that, you know, the first day, there's a number of runs in a POC with an adopter. So the first day you still should be able to be in production. And in Bauplan, you saw before, like it doesn't take 4 hours. Like it takes literally 4 minutes to run your pipeline. And then when you get a bit better, you want to do more complex stuff, right? So API needs to be gradual. So it needs to be easy for me to go to the next step while I figure out how the first runs work. And then of course, you know, API needs to be flexible because more people will join Bauplan organization in your company. They will have different use cases and your API needs to somehow be flexible enough for you to accommodate all of that, right? And that's what we're striving to do. And when you do that, you find out that the usage inside an organization, you know, like go very, very fast, very, very high because of how easy it is to adopt. And finally, since unfortunately I have to say the word agents 1 before the end of this presentation. So we're going to release soon a paper with Together AI called the Agentic Lakehouse. which is of course, is a bit of a marketing term, but is actually correct. And this stems from one of the fundamental axioms of informatics, which is make something idiot-proof, and somebody will come up with a better idiot. Okay? And so what is the most idiot thing coming around lately? And of course, it's large language models, right? So it turns out that if you develop your entire platform so that interns can learn it in 10 minutes, you know who else can learn it in 10 minutes? Well, Claude or ChatGPT or whatever. So when you think about what agent needs, they need easy API, check. They need declarative infrastructure, check. And they need the possibility of making a lot of mistakes without, fucking things up for everybody else, check. So Bauplan is already an agentic lakehouse. You can actually use now Claude, for example, to repair your pipelines into Bauplan, right? Because the entire system is an API, and Claude, with a few tool calls, we have an MCP server that is open source, can actually figure out what was wrong, the state of the system when it was wrong, open a branch, change the code, run the code, submit a PR to you. Okay? So while of course there's a lot of hype into this, and if I take off my Silicon Valley hat for a second, there will be more and more data work that gets automated. This is not a question of if, it's a question of when. Okay. It's false that today is all automated. Okay, it's false that tomorrow is all automated. Okay, but when you see Claude, which we call Claudio in our company, when you see Claudio actually fixing a pipeline in Bauplan by itself, it's magic. Doesn't work all the time, but when it works, it's really a glimpse of a future where things are built very differently. I just came from VLDB, which is the most important database conference on the planet, where Aditya from Berkeley presented a paper that is just released 2 days ago on the archive that is called, I think, Pleasing Our Overlord or something like that. But it's basically the idea that our data system will not be used by humans anymore statistically. So all the things that we build, remember the GUI, the stupid notebooks, all the things that we build, they're like completely the wrong abstractions. I mean, they wrote the wrong abstraction even before, but people didn't figure it out. But but now it's even clearer, even to the people that are, not the best and brightest among us, that there is like not the right thing to do. Okay, because agents have very different access pattern and very different way of building stuff. So this will come. It doesn't come tomorrow. It doesn't come a year from now, but this will come. And the best way to prepare is, is not to retrofit something that it was obviously built for another time and age to do it, but it's probably built something that is like, built for people to, for people or agents or whatever to be easy to reason about and automate. Of course, I had to skip through a lot of stuff, but again, thanks God, all of this is online. You can read all of our papers that go in excruciating and pedantic details in everything that I just told you. Plus, we have a very engineering heavy blog post as well. If you want to go to that, or you can just ask me a question or send me an email. But if you like about any of these topics, please go online, read our papers, and let us know what you think. So, 2 lessons that I want you to take home. Most, maybe not all. Maybe not all and every single lakehouse use cases can be thought about this, but the majority of lakehouse use cases can be served by a FaaS model. Remember, only FaaS. And then composability allows us to explore the design space much quicker and much faster. If we had to rebuild all the things by ourselves with our resources, it would be impossible to bring this product to market in only 18 months. Okay? And the reason why we do this is because we're sitting on the shoulder of giants, and because we're part of a community, including the Python community, that has been so good to us, and we will try to be good too in return. Sorry. So we're gonna leave you with my quote. I don't know if we're right or wrong. Of course, we're obviously on a very niche. Like most of the world obviously thinks that we are wrong, if you do statistically, of course. But still, is no way to live. Like thinking what other people think is no way to live. I love you with one of my favorite quotes by Hardy, the mathematician, not the actor, that says, "It's not worth an intelligent man's time to be in the majority, because by definition, there are already enough people to do that." Thank you very much.
Thank you, Jacopo, for this great talk. We will now take questions related to the technical talk, and then we'll sit down and start asking him about anything. I mean, just throw him anything. I think he can handle it. I mean, he speedrun the building of a company. So, who has the first question here? wait, because this will be recorded.
So my question is about the function as a service part. So AWS Lambda and all these hyperscaler services are cheap because they have a very large scale, right? So it's cheap for them to schedule your function because they have thousands of servers sitting there, and they can use also spare capacity for that. So and I think at that scale also Bauplan FaaS model will work very well, but I think it's a bit harder to make it work at a lower scale. So when you are running Bauplan on your hardware or your EC2 machine, which anyway you are gonna pay full, how is it possible to amortize the cost, or do you have a vision where you're serving Bauplan again as a service? So it's not my hardware, it's not my EC2 machine, but it Bauplan EC2 machine, and I pay credits or whatever.
So there's a few things there. There's a few things there. One thing is that Bauplan doesn't bill you by usage, so we don't have that problem. We bill you by capacity. Like you tell me how much stuff you want to up concurrently, and I provision that. Which means that you can run unlimited amount of compute inside of the box that you have, and it's my job to schedule it for you. So it turns out that it becomes 5-10 times cheaper than the equivalent workloads anywhere else. Because everybody else is telling you that each step of the pipeline you need to spin up a Spark cluster because you can't even have two pandas version of the same thing. The Spark cluster is going to take 1,000,000 hours going up. It's going to be super slow, and it's going to be underutilized most of the time. Why? Because you are worried about Spark and so you're going to provision more. But then when you run the second job, you kill that one and you start another one. And so you end up with a bunch of things that are completely over provisions and mostly empty at the time. If you run enough pipeline, you have the equivalent of something that is 24/7 up, but you're paying, Snowflake or Databricks overpriced on EC2s, which is like 5 or 10x depending on the price you do. In Bauplan, it's the opposite. Like, you pay for capacity, so if you don't use it, it's your fault, but you pay a much, much smaller fraction of that, and you can throw as much compute as you want. In fact, you can run 2 concurrent Airflow stuff, and they will run in the same capacity, provided that they can, and we make sure that they do. So if you run, the more you run, the less you pay. So this is due for a few things. One insight is that even in our previous job, a lot of people will buy Snowflake warehouse and say, "Oh, Snowflake is very cheap. Like you don't pay if you don't run it." Then you can just download the chart of like how many times things run, and it's the entire day. Because Snowflake won't kill the warehouse immediately. If somebody else just run a select one in the meantime, the warehouse stays up. So you're paying on-demand prices for what is effectively full consumption. And again, Snowflake has no incentives of packing many queries, even if they can do that, because they want to spin up more stuff. So you end up starting with our previous company. We started with a public company, starting with hundreds of thousands of dollars in Snowflake, which was like, oh wow, this is cheaper than Redshift at year 1. Year 2, we were already, very, very close to, a very different order of magnitude. And people are like, wait, what? What the fuck happened? It's like, yes, because now everybody's running a query all the time, and that's what you actually end up with. So when we build Bauplan, one of our intuition is that the vast majority of workloads in data can wait a tiny bit. So if you can wait a tiny bit, because you run something every hour, but can be every hour, can be every hour and 3 minutes, can be every 59 minutes, doesn't really matter. You probably wouldn't notice anyway. That gives me the lee room as a provider to play Tetris with your functions and make sure they run for you as cheaply as possible. So like a huge insight that we have is that the vast majority of data work, that's other people that said it's not like that we invented this, is that most data work can wait a tiny bit. You know what I mean? Yeah. And so in most work can wait, now I can arbitrage all of that. And then the question becomes, how can you schedule function effectively without, that's a very hard problem, and there's a paper on it, and we're working actively on this. It's a very, very hard problem. But this is one problem. We have one problem. We need to schedule that. There's one problem we have.
The follow-up question would be how you understand the shape of the Tetris pieces, because to you they are Python functions, you don't know much.
True. But since the signature is like there's typically a relation between how big is the size of your input and how big is the size of your output. That's it's a very good proxy for that. So if you can do good cardinality estimation, it turns out you can do that. That's not what we do today. That's too advanced. We haven't done to that. What we do today is exploiting another fundamental fact about OLAP, which is 80% of things you see them twice or more. The vast majority of OLAP use cases, that's a million induced traces you can find, are repeated queries. Which means that if you just remember what I did last time, it's better than an educated guess. And again, there's like extensive literature now on this. But of course, again, other providers don't want you to know that. They want you to spin up a new cluster all the time. And again, this is totally possible to solve, but do they have an incentive to solve it? I don't know. The point is I don't have an incentive even to tell you to run more on my system. So the good thing is that when I tell you, hey, if you want to run a query instead of Bauplan, you can run it on Snowflake, because price performance is better there from this query, and I believe that. It's be my guest. It's a lakehouse, it's open, we don't lock you in, be my guest. Some of our customers started with Snowflake, and they're like, you know what? 90% of this bullshit can go out of this, cost a third, and I can do it in Python. Last 10%, stay in Snowflake, just point the external catalog of Snowflake to Bauplan, and everybody's happy. So interoperability is also important for us. But I think when I talk to the customer, they understand they have no incentive of selling that too. I don't decide to sell you more queries. I have zero incentive of doing that. I mean, I'm happy if you use it more, but it's a much less direct impact than when the Snowflake sales representative comes to you and say, hey, you need to migrate to Snowflake because every time you run ding, ding, ding. I mean, Databricks bills you even if when you, they bill you, they send you a bill for that, so.
More questions?
Is it possible to have some examples of use cases that are not compatible with Bauplan?
Yeah, absolutely. So Bauplan works. So there are two things. We don't do anything that is serving or consider real time. I'm gonna say why real time, in the sense that if you need something that reply to you in 100 milliseconds, this is not the platform it is. Honestly, no OLAP system is the same case. Like even Snowflake would be too slow for that. So that's definitely not your ballpark. The second thing is that Bauplan scales vertically every function. There's some nuances to this, but we can get into this. Scale vertically every function, but it doesn't scale the same function horizontally. Okay, so our sweet spot is like if your workload is between 0 and 150 gigabytes. Okay, that's probably faster and better than anything else. If you're moving a terabyte data, not the system for you. I'm not saying you have a terabyte of data, and there's a big distinction between the data that you have and the data that you read. Okay, so which again is another insight. A long time ago, I wrote a paper called "You Do Not Need a Bigger Boat," and it was the idea in 2021 saying that a lot of people at the time wanted to do distributed training for machine learning. And it's like, guys, you don't really. I do this all the time. You don't really need that. And there's a bunch of traces that have come out in the industry after when I said that the first time. You can see the Redshift paper from Amazon last year at VLDB. The P99.9 of the entire Redshift fleet for memory usage is 200 gigabytes, which means that 99.9% of the queries you ever run can run on Bauplan. If Redshift will take the 0.1% and I get the 99.1, I'm fine. I think I'm good. I think I'm good. But it was like another thing that people don't realize that Spark started by Mattei. Spark was an incredible engineering invention at the time. When the biggest EC2s was as big as our Lambda today. So people tend to really forget that you can buy a terabytes of data in AWS for much less than when I pay a single engineer in my company. Like compute is not expensive anymore. And going distributed if you don't have to is the hallmark of all problems. Okay, because you're gonna have you're gonna have the Scala traces in Spark that you don't understand, you're gonna have special people that you need to hire, all of that. Scaling VER 25, you can. And if you cannot, you probably have a special team anyway. But you don't need a special team for the things that actually Fortune 2000 runs every day. Like you don't. That's the underlying message. But if you do, Bauplan is off for you. If you're Pinterest, Bauplan is off for you.
So thank you. You made Bauplan. Seems like he can build lake houses as a piece of cake. Two questions. First one is, can the user swap the components that are built into Bauplan? Like, let's say, instead of iceberg, I want to use Delta Lake.
No, you cannot.
Okay.
There's like things that are principle and things that are an accident. This is an accident in the sense that we started with Iceberg 2 years ago when the community was very different. It was a bet that paid off massively. And the reason why we started with Iceberg was the only format that felt like a free format. Then of course Database bought Tabular and so on and whatever. But at that time it was a good bet. And the community now is kind of proving that this is okay. It's probably not the best technical format. Like there's a lot of issues with Iceberg, but there's also a lot of issues with Microsoft Words and people use it. But so if tomorrow we have an integration with Delta, I wouldn't be super surprised because our user at the end of the day express things that the logic are like the insight about like there's no iceberg in Bauplan. If I don't tell you that they're iceberg, you will never see it by design because that's an implementation that you shouldn't care. You just need that something looks like a table and is consistent like a database. So if tomorrow Delta is better, it's our job to swap it out and give you the option. So that's a kind of a contingency. We could have Delta, but we don't. And there are things that are a bit more ingrained in how the system works, like our FaaS, for example. Like if you want to swap, run C for gvisor, I mean, it's a very technical thing, but like you can do, we own that piece of thing in the sense that you can go to Snowflake and say, can use my query optimizer. No, it's their prerogative to do.
Okay. The second question is about the Git for data. Sounds great, but can you deal conflicts? Can you handle them?
There's like the short answer, and the longer answer. The short answer is you now don't want people to fuck up their data, and so you tend to be very conservative about this, right? So for example, right now we block a merge that in theory we could allow, but since you cannot be 100% sure, we just prefer for you to just basically try again. Remember, in Bauplan everything is code, so when you typically have a conflict because the downstream table has already updated, you can just rebranch, run. Like it's basically a no issue, right? As everything is code, you just need to fork again and run it. The true answer is there are cases in which, depending on the function that you write, that you could be a bit better in understanding merges, and part of our work with formal verification detail the exact conditions that you can have to be safe when you merge. Typical example is if I append something to a table and you append something to a table, we change the same table, but at the end of the day, these two things can be permuted, so it means that the merge will be safe to handle. Okay, so there are cases in which we'll be able to do that. Iceberg doesn't have primary keys anyway, so you can check it anyway. So you know what I mean? So that's a longer answer, but definitely for today, it's better not to fuck up your table than to try to be too clever about it. Also remember is like all up team, of course, they're like, but we're not like they're rarely company with 100 people in data engineering or stuff like that, right? There are people that are dozens, and so even big companies. So the number of people working at the same tables at the same time tends to be almost negligible.
But it takes 3.
yeah, it takes 3, but really focus on that specific table. Yeah.
Let's see if we have another question with the scope of this talk, and then we open up the scope so you can go back to the talk again later.
Hi, thanks for the talk. So I really like that you mixed many things like functional programming, databases, composability. You're also taking information hiding also because you hide most of the things. My question is really really clear is how would you take, so you're targeting AWS as a cloud. How would it take you to move to another cloud?
I mean, again, the short term is like we target AWS because we are AWS people, and most of our customers are AWS. AWS is by far the biggest cloud there is. So if you need to start from one, you start from one. But it turns out that it doesn't really matter because the only thing that we need to run stuff is something that is a virtual machine in which we install our binary that does the magic of the FaaS, and then object storage, which every cloud has. So if some client comes along and say, hey, I want to try this on Azure, like it's fine. I think it's worth to do, but it's like, you know, it will be trivially pod. That's what I'm saying. The first client that is, you know, that is worth enough to do it, we're gonna do it. We just didn't prioritize it because of our customer in AWS, and it just, you know, the system way we know better. But there's absolutely no reason why this doesn't work. The separation between control plane and data plane is also made to make sure that the data plane has such basic components that they will work in any cloud, which is virtual machines and object storage. Okay. So as long as you have that, we could in theory deploy it to your bedroom if you have an EC2 standing. Sorry, you have a machine standing there.
Okay. Yeah. Thank you.
Thank you.
Okay, so let's switch to the second part of the evening, which is an Ask Me Anything part. And I'll start it off because that's one curiosity that I have. Okay, so for those who are following online, this will change. It will not be recorded, and it will be an Ask Me Anything, and I will try to answer with a pizza inside my mouth.
It's a pizza. It's a Ask Me Pizza.
with a pizza challenge, additional challenge, because we are 10 after 8, and if you want to also consume the buffet, that in the end we had a buffet thanks to Sim System. So let's eat it. And we have the next meetup will be in October, beginning of October, and we are finalizing the details. We'll see what comes up. Thank you, everyone, and thank you again, Jacopo.